Today, we're gonna have a fair day because tomorrow we are going to rest. So yesterday I gave you a homework. Oh, by the way, we're in the Natural Sciences classroom. I'm still your host or presenter, Kulsani Mbata, and you can still find me on Twitter at MbataX or Instagram at XKIM. So yesterday we did have a lesson and it was great. We have a homework, but before we go to our homework today, I want us to look at what you're going to learn today. Today you are going to learn the following. We will learn about magnetic and non-magnetic materials. Then we're gonna know what is a force of attraction, where do we experience a force of attraction, and what is a force of repulsion, and when do we experience a force of repulsion. We're gonna know about like poles, unlike poles, and electrostatic force. I hope everyone is ready for our lesson today. And then when we continue, we will be looking at our homework. I hope everyone did their homework. Let us look at our homework from yesterday. So, who discovered the law of universal gravitation? So we all now agreed that it is known as Newton's law of gravitation. So the correct answer there is A. Is A. So it's Newton. Newton discovered that law. Then write corrections if you chose Einstein or Kepler or Planck. So what is gravitational force? Is it A, a repulsive force between any two objects with mass, or B, a force of attraction between two objects with mass, or C, a force between any two objects whether or not they have a mass? Which one is it, grade 9s? Which one is it, grade 9s? Anyone who got the answer for that one, raise up your hand. Raise up your hand if you know which one is a gravitational force between the three. Is it A, a repulsive force of, yes, Bongi, I'm asking you, I can see you, Bongi, there. So tell me, Bongi, is it A, B, or C? Which one is it? Which one is it? Is it A, a repulsive force between any two objects, or a force of attraction between two objects with mass, or C, a force between any two objects whether or not they have a mass or energy? Which one is it? Who wants to take me on? Rowan, I see you're in class, and I saw Bugs came in the class early today. Daydara is also in. Which one is it? Which one did you choose and why? I'm waiting on you, grade 9s. I'm waiting on you, grade 9s. Which one is it? Which
B, sir.
Is?
Says B.
It's B, yes. Okay, it is indeed B. Why is it B? Because it is a force of attraction between two objects with mass. Because it cannot be A because it's it's a repulsive force. We haven't done anything about repulsive force, so you know nothing about repulsive force, and it also can be C. So the correct answer is B. And then let's move on, grade 9s. I will need you to interact with me on the next slide. Please be prompt. So here you are asked to state whether the following statements are true, false, or partly true. You need to state whether they are true or false, or they are partly true. So you have the following one. Friction always slows things down. Friction always slows things down. Is it true, false, or partly true? Grade 9s, let us work. Anybody can open the mic and talk to me. Anyone? Which one is the correct answer there? Is the friction always, does friction always slow things down? Grade 9. Let us work together. It's a homework. Everyone did their homework. So what did you write? What did you write? I see my home girl there. Tembe Gambata just joined. Which one is it? Where is Unkabetsi? Where is Nkosi? Where is Bucks? Where is Rowan? Where is James? I saw Amra earlier on. Where are you guys? Let us work. Yes? Okay, and then friction always slows things down. Is it true, false, or partly true?
Partly true.
Partly
It's
true. Partly
Thank
true.
you very much. Thank you very much. Partly true. And then the correct answer is partly true because the friction is different, remember? So it's not always the case. For example, we can look at the sliding friction. It doesn't slow anything down, that one, and so on and so forth. Cars need friction to keep moving.
True.
Huh?
True.
True.
Is it true or partly true or false?
Yeah.
True.
It's true.
Yeah.
True.
Rowan, why are you late today? Why is Rowan late today? So the correct answer there is true, friction. Because without friction, the car would not ever be able to stop or actually interact with the tire so that it keeps moving. You could walk without friction. True or false, grade 9?
False.
You could walk without friction.
It's false.
Huh?
False.
False.
True.
Yeah, the correct answer is true.
How come?
Because when you are walking, you are lifting up your feet and then you move. You do not keep, or there is no, you are not sliding. So remember that if you keep on, it's left, right, left, right, left, right. So you are picking up your feet every time you are moving. The only
I
time you
drag
are
my feet.
that's being lazy. You don't have to drag your feet. And then matches light because of friction. True or false?
True.
True.
True. Thank you very much. It is true. Remember that we said friction sometimes produces heat, right? So this one, it is correct. It's true. Let's continue. Grade 9. You could not pick up a cup of tea without friction.
False.
False.
False. So now you see you could walk without friction as well, because you pick up your feet every time you walk. False. It's false here. The next one says friction is useful in playgrounds.
False.
False. Partly true.
False.
Friction is useful in playgrounds.
Partly true.
False.
It's partly true.
Partly true.
It's hardly true.
It's
I can see people who are not active in sports.
Yes.
So they are not active in sports. Please let us obey the Wednesdays and Fridays. Let us go to the soccer field or whatever field. Pencils do not need friction to ride.
They do.
Huh?
False.
Do not need friction to ride. False. Let us actually read and understand. There is no friction when you are roller skating.
False.
false.
It is indeed false. There is friction.
Go tsagalang ka speaker sa ka.
And why do you rapid failure, rapid use? Shoelaces stayed tied up because of friction. This one.
False.
False.
Huh?
False.
Why?
Yes.
Skating on ice.
Huh?
They're not
Because you're
moving when they
skating
tied
on
up
ice.
together.
But why do they stay tied up? What makes them to stay tied up?
Tension.
I also thought it was tension, but apparently shoelaces stay tied up because of friction. Actually, that statement is true. So now, yes, let us look at them when you tie them up together, and then for the mere fact that they come closer together, what happens is that there is friction between those two threads of string. Do you understand? The tension is to make sure that they are tightened up, but what keeps them together is tension, is friction between the shoelaces. Remember when you are tying up the laces, right? And then what happens is that when a lace is touching another lace, there will be a friction. And again, if you can rub two strings or those two laces together, you will feel the heat. Have you ever tried rubbing the shoelace against your skin? You will feel heat, and that heat is as a result of friction. So shoelaces stay tied up because of friction. The statement is true.
Yes,
Thank you very much. Thank you very much for not getting a total. I was worried now. I don't like kids who get total. The last one. Snow increases the friction between your shoes and the ground.
Partly true.
partly true.
Guys, let us actually read the statement again. Snow increases the friction between your shoes and the ground.
False.
Yes. Who has a problem on Saturday? How much did you get, guys? Did you get 10 out of 10 for this true or false, partly true statement?
No, sir.
James is late today. Okay, any question based on our homework or anything that we were doing yesterday? Any questions? No questions. Let us continue. Remember that the slides will be available for you when you need them. And then anytime you need them. And you know that. Let us look at magnetic and non-magnetic materials. What are we talking about when we're talking about magnetic and non-magnetic materials? So the metals, iron, cobalt, and nickel are magnetic. And some human-made materials such as steel are also magnetic. This is because steel contains iron. So we are dealing with non-magnetic and magnetic. So magnetic stuff. Remember when we were doing iron, we said we've got iron, which is a rust. Obviously, it is not magnetic. And then we've got iron, which is magnetite. So we're talking about that material which attracts other metals such as iron, cobalt, and nickel. Then types of magnetic forces, grade 9. Please know these types of magnetic forces. Unlike gravitational force, magnetic forces are not always pulling forces. Remember that gravitational force, it is always pulling, but unlike that with the magnetic force. So we've got two types of a magnetic force. We've got a force of attraction and a force of repulsion. A force of attraction is a pulling force that two objects exert on each other. So we will learn why do these two objects attract each other? Why do we have this force of attraction? And then we've got a force of repulsion, which is a pushing force that two objects exert on each other. Force of attraction, friends. Force of repulsion, enemies. They don't want each other. Then a magnet has a north pole and a south pole. So for example, we will have a force of attraction if between north and south pole. North and south pole. Then we will have a repulsion if we have a north pole and north pole, or south and south. So we get what you call a force of repulsion. So let us look at this. If we're talking about north and south, those are unlike poles. And then if we talk about like poles, we will talk about north and north or south and south. So we say that like poles repel each other. So which force are they experiencing there? It's a force of repulsion. Like poles repel each other. When two magnets face each other with different poles, they will pull towards each other. I've explained that. If two magnets, so a magnet, any magnet will have two poles, a south and a north pole. And then if you take two magnets and you make this one with the north pole face this other one with a south pole, they will pull towards each other. I'm sure everyone has had a magnet in their hands, and then in the meantime you put it next to what you call next to the steel. You will see that the magnet moves towards the steel. Then we say, okay, maybe we can conclude that a magnet has a north pole and a steel has a south pole. A magnet has a north pole, remember that, and a south pole. So you won't say it has only this type of pole. We say that unlike poles attract each other. Unlike poles attract each other. Unlike poles attract each other. So let us look at this. Like poles, similar magnetic poles, that is north and north or south and south. Unlike poles, different magnetic poles, that is north and south. You see the difference between the two? Like poles and like poles. Do not make a mistake there. And then magnetic field on Earth or of Earth. So we all know that Earth is one large magnet. When we were talking about yesterday about a gravitational force, we said we all know that the force of gravity always pulls you down, and you are also pulling it up, and then because of the balanced forces, you won't actually experience any difference because of the balance forces. So now you need to actually incorporate everything that we've been doing with these forces so that you understand this one. It has a north and a south pole. So like all magnets, Earth has a magnetic field around it, which is a result of electric current that is constantly circulating within it. So there's a current that is obviously is constantly circulating around us. And remember that we said the wall is also attracting you, and you're also attracting it a tiny bit, and then the tiny attraction there is balanced, and that's why you don't automatically go to the wall or the wall comes to you. So that's the type of currency that we are talking about here. Then the geographical north pole of Earth is attracted to the magnetic north pole of a compass, which is used to guide us with direction. I'm sure everybody has seen the compass. So that you see the north on your compass there is your north pole, and the south there is your south pole. Mostly, if you're looking at us, we are in South Africa. That means we are at the south pole, and then there is a north pole. Those people who are in colder areas, they are in the north pole. I'm sure you all know that by now. And then let us look at what is an electrostatic force. So grade 9s, if you continue with physics next year, you will be calculating this, and sometime this year, I'm not sure if I did include it in a homework, today's homework, how to calculate an electrostatic force. So you need to know these things of repulsion, you need to know these things of attraction, like poles, unlike poles. These things will be driving you into understanding. So let us look at electrostatic force. An electrostatic force is a force that two electrically charged objects exert on each other over a distance. So they do not touch each other, but there is a force between them. And this force, because they are electrically charged, and then we call them electrostatic force. Are we clear on that one? And then Rowan has a problem. The system keeps on kicking him out. I don't know what's wrong today. Electrostatic force acts in an electrostatic field. So now an electrostatic field exists around any charged object. Any charged object will have an electrostatic field, and then it will have an electrostatic force. An electrostatic force is experienced in an electrostatic field, and then anything that is electrically charged has an electrostatic. Are we clear on that one, grade 9? Yes, I know there's too much electro. Then let's move on. Remember that all substances are made up of tiny particles called atoms. You did this last year and last year, the year before last year. Yes, you know that every substance are made up of tiny particles called atoms. An atom consists of small nucleus with a cloud of electrons spinning around the nucleus. So these are positively charged protons, and neutral neutrons are held together in the nucleus by very strong forces. So now you can see that most of the things are actually charged. So if they are electrically charged, that means they've got an electrostatic field that they obviously possess an electrostatic force. So we don't know if it's a force of attraction or a force of a repulsion. So it takes enormous amounts of energy to split the nucleus. It takes enormous amount of energy to split the nucleus of an atom apart. Under normal conditions, the protons and the neutrons of an atom remain inside the nucleus. So, what is exactly an electrostatic force? It is a force that two electrically charged objects exert on each other over a distance. So these are not contact forces. So we can conclude by saying an electrostatic force is a non-contact force. So everything that we've learned about non-contact forces applies to our electrostatic force. Any questions so far, grade 9s? Any questions so far, grade 9s? So an atom as a whole is electrically neutral because the amount of protons is equal to the amount of electrons. We all know from our acids and bases, the pH scale, what we know about pH scale. So if it's neutral, it is neutral. So electrons can be removed from or added to the surface of a substance fairly easily. So you can add electrons on a substance. It is fairly easy, unlike in the reaction though. So one way is to rub together substances, or if you want to add or remove the thingy, you are adding when you are rubbing your hands together. That's why you get that friction, and that friction produces heat. And then this can make electrons move from one substance to another. So now what happens if you actually, if your face is cold, you can rub your hand. Once they are warm, you put them over your face, and then your face will become warm. That's another way. The substance that gains electrons become electrically negative. The substance that loses electrons become electrically positive. So the hands will lose your electrons to your face, and then you understand what's happening. And then forces between like and unlike charges, grade 9. Like charges, similar electrical charges, that is positive and a positive, those are like charges, or negative, and negative, still like charges. Unlike charges, different electric charges, that is positive and negative. So like and unlike, we still continue with the notion of the poles as well. We've got like poles and unlike poles. Then we said poles, we use the south and north. And then for like and unlike charges, we use negative and positive. So, as in case of magnetic force, an electrostatic force can be a force of attraction or a force of repulsion. So, an electrostatic force can be attracting or can be repulsive. It will depend on the situation at hand. Like charges, remember, like charges also repel each other, and unlike charges attract each other. Electrostatic potential. So now electrostatic potential energy is the same. The potential energy, I will give you the formula for potential energy and kinetic energy Monday. You can calculate these things. But for us to understand what exactly is a potential energy is energy that is stored in a system. When you lift a box above the ground, you have to do work to overcome the gravitational force of Earth on the box. So that's how you're going to now, once anything you carry it, and then you will experience potential energy. If you hold the box above the ground, the box and Earth form a system. Are we clear? So the system stores gravitational potential energy. If you let go of the box, the stored potential energy now, because there's a movement, the stored potential energy is changed to kinetic energy as the box falls. So now you will know how to calculate the potential energy and the kinetic energy. Remember, the height, once you have a height, lifting the box up, there's a height between the ground and the box, and then that is potential energy. But the energy of the box falling down, when you are letting go of the box, then the potential energy, that height, remember, there is now a movement of the box falling down, and then that is actually kinetic energy. I hope you understand the difference between potential energy and the kinetic energy. For you to actually remember this for me, stationary above the ground is potential energy. Above the ground, but there's a motion, then that is kinetic energy. I hope you understand that one. Take note, grade 9s. Non-contact forces or field forces are exerted over a distance. The objects do not have to touch each other. So that's a non-contact force. Then gravitational force is the force of attraction between any two objects that have mass. Gravitational force is the force of attraction between any two objects that have mass. Then magnetic force is the force of attraction between unlike poles or force of repulsion between like poles. So now remember that now with a magnetic force, I've shown you three types of forces in this slide. We have non-contact force, we've got gravitational force, and we have magnetic force. There are three there. And you can see the difference between these three types of forces. Are we clear? But being the mother body there is a non-contact force. So the gravitational force doesn't have to be a contact. For magnetic force, it also doesn't have to be a contact. But now that attraction that happens, either be a like one or unlike one, it is still a magnetic force. And then electrostatic force is the force of attraction between unlike charges or the force of repulsion between like charges. That one we have dealt with it, grade 9s. Then you have a homework, grade 9s. There is a homework, please write it down. So number one, they say to you, write down the correct scientific term for each of the following statements. A push or a pull, the two types of force exerted when two objects are in contact. The type of force exerted when two objects are in contact. A force exerted by two magnetic materials over a distance. The type of force exerted when two objects are in contact. That's B. C. A force exerted by two magnetic materials over a distance. D. A pulling force that bodies exert on each other over a distance. A pulling force that bodies exert on each other over a distance. E. A force that two electrically charged objects apply on each other over a distance or exert on each other over a distance. 2. Discuss the difference between mass and weight. Discuss the difference between mass and weight. Number 3. Calculate the weight of the following objects on Earth. A boy with a mass of 52 kg. A boy with a mass of 52 kg. B. A 250 grams packet of sugar. 250 grams packet of sugar. Number 4. State 3 types of contact forces. Number 4. State 3 types of contact forces. So, in our next lesson, we will discuss electrical cells and energy as energy system. In our next lesson, we will discuss electrical cells as energy systems. We still have that link that can actually help you with further information there on our slides, and then you can actually follow us on Africa 10 Gigs or at Africa 10 Gigs, at Aziora, at BDESA, or Sasol Foundation at Sasol SA, or you can hashtag us at hashtag STEM Champions. Any questions, grade 9? Any questions, grade 9?
Sir,
Yes,
please go back to the first slide of homework.
I'm here now. Yeah, there we go.
Thank you, sir.
Any questions, grade 9? Any questions? So on Monday, you'll know the types of electrical circuits. What is an electrical circuit? You also know the parallel and the one in series, the series cell and the parallel circuit. Types of circuits, we have two types of circuits. It's a parallel and it's a parallel circuit and the series circuit. Second part of our homework. There we go. Any questions, grade 9? We have time so that I can explain anything that we have done this week, if you have any questions. So since we do not have any questions, grade 9, can I wish you a great and enjoyable weekend. If you've got any questions, you know how to touch base with me via my social media handles or my email address. To those of you who have it, they can continue the conversation over the weekend. Please do your homework, and so that you are ready for school when you're going back. And remember that you can still ask questions if you've got any questions concerning your first term, second, and like when we're talking about body systems and everything, plant cells, or you can ask questions with your chemistry. I know some of you still have a problem with balancing. If you still want us to go there and the reactions and the naming of the compound, I'm here. And now this week we jumped into forces, I'm still here. So guys, can I say